IELTS Part 148. 200 years ago, most people assumed that the ocean floor was similar to the beaches and coastlines. During the 19th century, attempts to produce maps of the seafloor involved lowering weighted lines from a boat and waiting for the tension of the line to change. When the hand line hit the ocean floor, the depth of the water was determined by measuring the amount of slack. Each of these measurements was called a sounding, and thousands of soundings had to be done just to get a rough measurement of a small portion of the ocean floor. Besides estimating the depth, these surveys helped in identifying large shipping hazards, especially near the shorelines. A naval officer published the first evidence of the underwater mountains in bathymetric chart in 1855. During World War I, scientists developed the technology for measuring sound waves in the ocean. Anti-Submarine Detection Investigation Committee ASDICS was the original name for these underwater sound projectors. But by World War II, the term sonar was adopted in the United States and many other nations. Sonar, which stands for sound navigation and ranging, was first used to detect submarines and icebergs, but calculating the amount of time it took for a sound signal to reflect back to its original source, sonar could measure the depth of the ocean as well as the depth of any object found within it. The first sonar devices were passive systems that could only receive sound waves. By the 1930s, single beam sonar was being used to transmit sound waves in a vertical line from a ship to the seafloor. The sound waves were recorded as they returned from the surface to the ship. However, this type of sonar was more useful in detecting submerged objects than mapping the seafloor. Throughout World War II, technology improved and active sonar systems that both received and produced sound waves were being used. It was the invention of the acoustic transducer and the acoustic projector that made way for this modern sonar. The newer systems made it possible to identify certain materials such as rock or mud. Since mud absorbed a good portion of the sound signals, it provided a much weaker echo than the rocks, which reflected much of the sound waves. The multiple beam sonar could be attached to a ship's hull and was developed in the 1960s. With this type of sonar, multiple beams could be adjusted to a number of different positions, and a large area of the ocean could be surveyed. Maps created with the aid of multi-beam sonar help to explain the formation of the ridges and trenches, including the Ring of Fire and the Mid-Ocean Ridge. The Ring of Fire is a zone that circles the Pacific Ocean and is famous for its seismic activity. This area, which extends from the coast of New Zealand to the coast of North and South America, also accounts for more than 75% of the world's active and dormant volcanoes. The Mid-Ocean Ridge is a section of undersea mountains that extends over 12,000 feet high and 1,200 miles wide. The undersea mountains that extend over 12,000 feet high and 1,200 miles wide These mountains, which zigzag around the continents, are generally considered the most outstanding topographical features on Earth. The invention of the side scan sonar was another modern breakthrough for the field of bathymetry. This type of sonar is towed on cables, making it possible to send and receive sound waves over a broad section.